So the last theorem then, it says if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So there's a lot to digest there. So if you can have some space, let me do this actually so I have a little bit more space, if it'll let me. We want to draw this in so you can kind of see what this is asking. Let me do it this way instead. So if you have some space, draw in a bisector or a segment. And then I'm going to draw in, remember yesterday we talked about a perpendicular bisector. So a perpendicular bisector would have to be perpendicular to this line and also bisect that line. So it would have to go right through the midpoint and it would have to be perpendicular. So for us right now, we're going to say that this line here, this is our perpendicular bisector. So what that tells us is these are congruent, these two segments here. Let's call this A, I'll call this B. What this theorem is telling us is if we have a point that lies on our perpendicular bisector, so recall now, our perpendicular bisector is this guy. So take your pencil and put a point anywhere on this line here. Put it anywhere on your perpendicular bisector. All right, so do that before I do mine. And the reason I'm going to do it after you, because most of you are probably going to put it up top, which is fine. I'm going to put mine down here. Can't put it down there. What this theorem is telling us is no matter where you just put your point, if I now take this point and notice how it says is equidistant. So think about what that word would mean, have an equal distance to the endpoints of that segment. So what that means is this point to B and this point to A. If this was 5 units, this has to be 5 units, must be. So if you drew your perpendicular bisector up here, let me even go lower right now. This perpendicular bisector point to this endpoint and to this endpoint, these would have to be congruent no matter where I draw that in. So if you drew yours at the very top of this, those two segments, this guy and this guy would be congruent. All right, so that's what that's saying. If a point lies on the perpendicular bisector of a segment, then it has the same distance from the endpoints of those segments. All right. All right, last thing, and then we'll start doing some problems. So an angle bisector is hopefully kind of self-explanatory. And you're going to have an angle, and it's going to be bisected. So if you remember, bisect basically means cut in half. So if you think about an angle, so draw in an angle. And then what this says, if a ray divides an angle into two congruent angles, then it bisects that angle. So let's take a point. Let me do it in black. And as best you can, draw a ray that extends out of here that just visually would appear that we're cutting this angle right in half. So if this was a 40-degree angle, then each of these would then have to be a 20-degree angle. So it's the ray that cuts your angle in half. That's an angle bisector. Okay, it's kind of self-explanatory, hopefully, with just the phrase. All right, so let's go through these now. So example number 7, it says, and know what these definitions or these notations mean. So notice how there is no arrow here, but there is an arrow here. So this is what we call a ray. So the ray drawn from K to O. So look at from K to O. So this is this ray. It bisects the angle drawn from J to K to M. So it's going to cut that big yellow angle right in half. Then I tell you that JKM is 58. So JKM, this big angle is 58 degrees. The question then is, what would, let me do this guy in just blue here, what would this blue angle have to be? OKM. Write that down. That's something hopefully not a lot of work here. We don't have to set up an equation right now. It's just understanding angle bisector, and then we should be able to get that answer. All right, what do you get, Cam? Good. What'd you do to get that? Good. The whole thing is 58 degrees. But if this ray is cutting it in half, that means half of it would be 29 here. The other half would be 29 there. That's what this was asking for. Each one of those angles would be 29 degrees. Okay. All right. Now we get into an equation though. So most of the ones we do, we kind of give you one with numbers. And then now we want to do one where you got to do a little bit of algebra. So similar setup. If I give you the measure of angle RAI, so here's RAI, that has a degree measure. So if we were to draw a little arc in here to show that that's our angle, this has a degree measure of 3x minus 5. And then angle IAN, so now here's I to A to N, the yellow angle there has a degree measure of x plus 27. All right, so we're given the blue angle, you're given the yellow angle. The last thing that you were given, which is very important, is the ray AI. So this ray right here bisects RAN. So this big angle here, so the overall angle, let's do this. So this big angle gets cut in half with this ray. So just like we did at the top, right? If I gave you the big angle, 58, and we have a ray that cuts it in half, don't these two guys have to be equal to each other? So same exact thought process. This ray is cutting this in half, so this angle here and this angle here have to be equal to each other. We just don't know their degree measure yet, but knowing that they have to be equal, that's how we get this problem started. We're going to say that the 3x minus 5 must equal the x plus 27. Those have to be equal angles in terms of their degree measure. There's our equation. And again, hopefully we're getting pretty good at solving these little equations from a while ago. Add your 5 over, then see if this is our answer, because we get x, so we get x to be 16. But if you look, we want angle RAI. So here is RAI, right? It is 3x minus a 5. So now I'm going to do 3 times x, which we now know is 16, minus a 5. So that is 48 minus a 5, which is 43 degrees. All right. Then if we know this is 43 degrees, right? Then doesn't this have to be 43 degrees? I could ask you what this big angle is, and we could add them up. So there's a lot of different routes we could take, but in this case, we should get 43. Okay. All right, next one. Let me fit this in here. So if we look up here, this is a segment, EH. So a segment just means we're going to draw a horizontal. It doesn't have to be horizontal, but I'm going to draw it horizontal. And a segment has 2 distinct endpoints. One of them has to be E, one of them has to be H. That segment is going to be divided by 2 points, F and G, in a ratio of 5 to 3 to 2 from left to right. So what that then means is we want our bigger interval. So let's move it over here. Don't draw a segment though. Don't draw a little mark. Put a little dot right here and make that F, because we're dividing it with F and G. Then we're going to have a point G right here. All right, because they tell us. So now put another point right there. They then tell us, and say that again. Couple reasons. One, we want to go left to right. So we want F to appear first, and then we want to move right with the next one. So G would have to be to the right of F, but E and H must be our endpoints. So E has to go here, H has to go at the end, and then the G has to be to the left of H. Right. It's got to be in between F and H. Okay. Thanks, Zach, man. Yeah. Then I tell you that the length of E to H is 30. So if I now do this entire length from the beginning of the segment to the end of the segment, I know that this has a length of 30. All right. And then they want you to find, or I want you to find the length of FG and then name the midpoint of the segment EH. So now let's go back to this little wording right here. So we don't know what these are, right? We dealt with one of these yesterday. You could do some guessing and checking, but that could take some time. But we don't know what one of these are. But then you're multiplying. So I suppose that is an interesting coincidence because 5 times 3 times 2 is 30. But what's that give us here, though, in terms of setting this up so we can figure this out? So here's what this is getting at. Let me show you this, Ahmed, and see if this makes sense. Let's say that GH was a 1. It's actually kind of tricky. Let's not do it with a 1. Let's do it with our variables. So we don't know what either one of them is. So think about this value of x that we're trying to figure out. Okay, that's our unknown. We're going to go left to right. So the first thing that appears on the left is 5, right? So whatever x is, this would have to be 5 times that x. In the middle, see how you have a length of 3 in our ratio? So don't we have this middle segment right here? So that segment would be 3 times whatever that x is going to be. And then the farthest right in our ratio is a 2. So this would have to be 2x. All right, you follow that so far? So what that now means is, doesn't 5x plus the 3x and then one more plus the 2x, don't all three of these guys have to add up to be the overall amount of 30? So we're going to add all those up. So you do 5x, 3x, and 2x. So 5, 3, and 2 make 10x. Those all added up equals 30. Solve that, and x is going to be 3. Even before we answer this question, now let's plug these in just to show how this now works. What this now tells us is 5 times x. X is 3. So this, let me just do it at the top. This has to be 15. 3 times 3 would be 9. 2 times 3 is going to be 6. Add those all up, they should end up equaling that 30. So if I now want you to find the length of FG, the length of FG would equal, FG was the blue region that I have highlighted right here. That's got to be 9. If I want you to name the midpoint, if this is 30, the midpoint should be directly in the middle of 30, which would be 15. So isn't F, don't I clearly have 15 to the left of F, but to the right of F, isn't it the sum of 9 and 6, which is also 15? So the midpoint is point F. All right, because we have 15 on each side. All right, that's definitely our middle. Okay. All right, I think this is the last, 2 more. Set that one up. This one, crossing my fingers, is nice. The graph is already drawn for you. See if we can get that guy set up. All right, let's see if we got this set up. This, I hope long-term would be an easy one. If it's not quite, you're not quite there yet to think it's easy, that's fine. There's plenty of time, but this long-term I think is a nice one. I'm telling you that C is the midpoint of segment AB. So that pretty much just means if this has a length of 20, then this would have to have a length of 20. They have to be equivalent in terms of their lengths. And then using that information, you're going to figure out what does the AC length, CB length, and AB lengths all equal. Well, if this is the midpoint, like I just said, if this is 20, this is 20, don't those two expressions have to be equivalent to each other? All right, there's not much you could do anyway because you can't add that and set that up to anything. And then we now solve this. So when we go through solve this equation, add your 4 over, and we find that x would have been 5. Plug 5 in right here. 2 times 5 is 10. Add that 1. That should be an 11. You could plug this in if you want, but as soon as we know this is an 11, this has to be an 11. So what's that? AC is the 11. CB is also 11. And then the last thing we wanted you to figure out is A to B. That's the entire length. And wouldn't the entire length then have to be 22? Okay. All right. So as these go, that's a nice guy. That's a nice one. All right. So now let's see. This one I would say is not a nice one. See if we can even put together with just understanding the notations. I don't give you this graph. Try to graph what's going on here. Because when we get to a quiz or a test, you can't even get this problem started if we can't sketch out what's going on. Okay, let's see what we came up with here. So this is a line. So when you read this, when it has that LK with an arrow at the end of each one of those sides, it's a line LK, is perpendicular to this, and it should bisect this. So what you really want to draw first is the segment TN. So if I draw in the segment TN, call this T, and this is N. Since you don't have arrows on the end, that's why we know there's a dot at the T and a dot at the end. Then I should have a line LK that is once again perpendicular to that and cuts it in half. So kind of just have an idea where the halfway mark is. You're going to eyeball it a little bit. So I would say right here, we should now have a line going straight down through that point that's perpendicular, so that it is not only perpendicular, but it is also cutting this in half. This is a line, so we would have arrows on the end of that. This is the line LK, so we'll put an L somewhere up here, and we'll put a K down here. Okay, so if we had that. Next thing, the intersection of those, the line and the segment is point F. So then this point right here, you're going to call F. And then I tell you that from T to F, so now we go from here to here, that's what you were given, that has a length of 3. And if we drew it right, you should be thinking this shouldn't be too bad. What is T? So now we want this whole length, T to N. All right, what do we think? Tn should equal what? Good. And how'd you get that, Ahmed? Yep. Good. If it's bisecting it, then that means if this is 3, this here must also be 3. Tn is the entire segment here to here. So 3 and 3 has to be a 6. And then the last thing, what is the measure of angle LFN? So angle LFN is here's L to F, and then come out here to N. So we're talking about this angle over here. Remember how it's a perpendicular bisector? So that guarantees that this is a 90-degree angle for all 4 of these corners. So this has to be a 90-degree angle. Okay. All right, now your homework, we'll do 1 or 2, we'll get you going, is page 49 and 50. So you're just going to do the homework. It should be the very next thing in your packet. But let me find some that maybe we haven't done. I really want to do the ones where you have to draw out the picture, because I think 1 and 2, hopefully with the picture drawn in, you'd be able to answer that. So jump to number 3 and sketch in, draw in what this is giving you. Once you have it drawn in, if you're confident in your drawing, see if you can then, now that we have variables here, almost certainly means you need to set up an equation of some sort. So then see if you can get that equation set up. All right, and let's see if we got this going here. So M is the midpoint of RT. So this we want to sketch out first. So what you are given is that we have a segment R and T. So there's no arrows on either end. So you're going to start at R with a dot, and then you're going to extend out to T wherever you think that is at, and then that should have another dot. Then you can go ahead and draw an M wherever you think the middle is at. So we're eyeballing it a little bit, but we're going to say that this is your midpoint. So what that then guarantees, we can mark this with our tick marks, is that this segment here is congruent to this segment there. You're then given that RM. So from here to here, this is 5x plus 9. And then from M to T right here, that is 8x minus 36. And since this is your midpoint, since we have these little tick marks indicating they're congruent, those two expressions can be set equal to each other. Most of the time, you're either setting them equal or you're adding them up, setting them equal to something else. Not always, but that's especially right now. And then we now solve this. So subtract your 5x. Add the 36 over. And we should have gotten x to be a 15. Notice x is not the answer. I'm not asking for x at all. What we're looking for are all of these lengths. So if I come over here, plug 15 into this. So I'm going to do 5 times 15 plus a 9. What is that? 75, so 84. So we know that the length of RM is 84. Doesn't that then mean M to T must also be 84? And then the last one, RT, is the entire length. So if this is 84 and this is 84, then the whole thing is just the sum of those, which is 168. Okay? Hopefully we got that, or came close. Okay, I'm good. All right, last one I want us to do together, and we'll cut you out here a little early if we have some time. Go to number 6. See if we can draw that. I think this is the last one yeah, because the rest are all drawings. So go to number 6. Yeah, Cam. I think that the real question, and I think why you're a little confused right now, is draw this in first. Read to yourself what that means, and then draw this in first. And I think it'll hopefully make sense then. Okay, because it's not a segment anymore, right? All right, and then let's go ahead and sketch this in. So when you draw, this is an angle. When we see this little notation here, angle, it really doesn't matter how you draw that angle. We really don't know the degree measure of this angle. So if you think this is some big obtuse angle, there's nothing wrong with you making this your J, this your K, and this your L. That's totally fine. If you think it's a smaller angle, what we would call an acute angle, that's also fine. You really don't know anyway. So neither one of them is necessarily correct right now because we just don't have the information to tell us which one is correct, which one isn't. So either way, we should be good. And then this is L. But what then should happen is no matter what kind of angle you have, you should now have this guy cutting that angle right in half. So now kind of to Cam's point, you're just going to estimate a little bit how we would cut this in half. So for this angle, I'm going to say it's right about here. If I have this angle, I'm going to go right here. What should then happen is, remember how we mark angles being congruent are with little arcs? So this arc here would be congruent to this arc here. Those have to be congruent. Same over here. If I had a smaller angle, these two arcs or angles are congruent. Then, no matter which one you wrote, I then tell you JKN is 5x minus 25. Let me label KN. So this was K, and we had to go out to N. So here's N. All right. Start at K, go out through N. And then angle JKN, so from here to here to here, that's 5x minus 25. And then NKL, NKL, that's 3x plus 5. Those have to be equal to each other if that big angle got bisected. Bisected means you cut it right in half. So we just take those two expressions, set them equal to each other, and then you're on your way. So subtract our 3x. All right, add your 25. And in regards to x, we get 15. Take your 15, substitute it in for one of them. So I'm going to do the 3x plus a 5. Let me do it up here. So the measure of angle JKN is 5 times 15 minus 25. So that is what, 75 and 20. So that should be a 50-degree angle. So then we now know that this was a 50-degree angle. Doesn't the other one also have to be 50 degrees? Yeah. And then this overall angle, if I ask you for that, would have to be 100 degrees. All right. So measure of JKN from here to here to here would have to be 50 degrees. All right. Okay. With that, the rest is up to you. I think there's just those 9. The rest of these mostly are going to be, I hope, nice. So you have the pictures drawn for you, and then just kind of use the stuff that we talked about yesterday and today to answer them. All right. So a little bit early, but we're good. If you have a question, feel free to hang out a minute. But if not, then we'll see you guys tomorrow. Okay. All right. See you guys. No bell today, Ahmed. Sorry. Unless you really want to hang out with Mr. Kubwitz and I for 3 minutes to sound your bell. You're